Welcome back to All This Math. This is Professor Parker. Make sure you are not signed in. Make sure you are locked in, meaning you're subscribed to the All This Math YouTube channel. Make sure you drop a comment below. Make sure you have your post notifications turned on. Make sure you share this video with somebody else. All right. Shout out to Cheney University, the historically black institution where I teach. I've been teaching that for the past 6 years, teaching math methods courses, and I also taught like a college algebra course one semester while I was there too. Um, the first historically black college. However, it was not the first degree granting historically black college, right? Founded in 1837 in South Philly as the Institute for Colored Youth, right around the corner from actually the first school that I got my first full-time teaching job from in 2005 in South Philly. All right. But at any rate, do your research on Cheney University and make sure you're familiar with all the historically black colleges and universities. All right. Now, what we're talking about today is polynomial end behavior. End behavior in terms of what the graph looks like, right? Because sometimes these graphs get a little complex. This is not that complex. You know how I know that? Because the biggest exponent you see is a 2, right? It's a quadratic, right? It's not to the third power. It's not a cubic to the third power. It's not to the fourth power, fifth power, sixth, seventh, eighth power, none of that, right? This one ain't too bad. It ain't too crazy, right? But still, we can identify what the end behavior is based on certain information. Now, you see LC. LC stands for leading coefficient. Think back to elementary school. Who was the line leader? The person that was in the front of the line when it's time to lead a classroom, go to the bathroom, go to the recess, go to the cafeteria, whatever, right? The lead coefficient is the coefficient that's in the beginning of the expression. You don't see no coefficient written here, right? Because what's understood don't need to be said, right? There's an understood 1 here. If there's ever no coefficient written, it's understood to be a positive 1. If there's just a negative sign in front, it's understood to be a negative 1. All right, so we got a positive 1 lead coefficient right here. All right, also the degree. What's the degree of this function? The biggest exponent is a 2, right? That a variable carries is a 2. All right, so the degree is 2. So we should write that information down. So my lead coefficient, as I said, is 1, and my degree is 2. Now, what do I do with that information? Now, the important thing about the lead coefficient is that it's positive. All right, it's a positive 1. That is important. And the degree is 2, so that's an even number. So the graph is going to look a certain way if the degree is even. It's going to look a different way if it's odd. So you got to know the difference between even and odd numbers, right? Also, the graph is going to look a certain way if the lead coefficient is positive versus it being negative. So you're looking for whether the lead coefficient is positive or negative, and you're looking for whether the degree is even or odd. All right, now, because the degree is even, so if the degree is even, it's either going to look one or two ways. It's going to end up going up to the left and up to the right, or it's going to go down to the left and down to the right. One of those two. Those are your two choices for the end behavior. The end behavior of the graph. All right. Now, what happens in between, we don't know. We don't know about all that. We don't really care about all that because we only care about the end behavior. The end behavior. This right end, this left end, this left end, this right end. So we care about. Now, because it's positive, your lead. This is what the lead coefficient. How do you choose which one? How do you know which one it is? Your lead coefficient is positive. It don't matter if it's a 1, a 8, a 7, a 39, a 262. It don't matter. It's positive. So that means that it's going to be this up here. It's going to go up. It's up. All right. If your lead coefficient is positive, it's up. All right. So we ain't worried about this over here. So we're going to have something that looks like this. And again, we don't know what's going on in between. And we ain't worried about that. We worried about the end behavior. Now, but how would we express this using x and f of x? Typically, on a classwork assignment or homework assignment, you might be given this. As x approaches infinity, x arrow infinity sign, the sideways 8, what is f of x doing? Right? You have to figure that out. So as x approaches infinity, right? Here's your x-axis. Here's your x-axis, right? So as the x values on the graph go that way, get bigger and bigger and bigger, go further that way, further that way, further that way, what's happening to the y values? Now, f of x and y are the same thing. F of x and y are the same thing. The y values are going up. They following the end behavior of the graph. They're going up. So then you would say as x approaches in positive infinity, f of x approaches positive infinity. Because up, all the way up to the ceiling, to the sky, wherever, that's positive infinity up there. Negative infinity is down. Positive infinity is up. Negative infinity is down. All right. Now also, but as x approaches negative infinity, what's happening? What's happening with f of x? So going this way, let's look at it like this. Again, x-axis on this graph as x approaches negative infinity, going that way, going that way, going that way. What's the graph doing? Vertically, it's going up. It's going up. It's going up. It's going up. So it's still going up. So whether x is going to the left, your x value is going to the left, the y's are going up. X value is going to the right, y's are going up. So that means that as x approaches negative infinity, I forgot my negative sign. Oh no, I had it, but all right, anyway. As x approaches negative infinity, f of x still approaches positive infinity. All right, that's about it. That's end behavior. That's what it is. All right, so that's all you got to do. So basically, as a quick review, look for your degree, the biggest exponent that one of your variables carries, and look for your lead coefficient. Look to see if your lead coefficient is positive or negative. Look to see if your degree is even or odd. Ain't much to it. Shout out to the HBCUs. I'll see you on the next video.